three major challenges the geologist faces when trying to decipher and then actually record what is in the subsurface. Let me explain these challenges in more detail. The first challenge for the geologist is being able to accurately account for the time lag between the time when the cuttings were cut to the time that it took for them to reach the surface. The second challenge for the geologist is to be able to recognize and correctly place the different cuttings in the correct zone. For example, because not all cuttings rise to the surface at the same rate, large, low-density cuttings can rise faster than small, high-density ones. In addition, particles from re-drilled portions of the well may have fallen into the hole because of clay swelling or may have sloughed off from the formations further up in the hole and can become mixed with other samples of cuttings deeper in the hole. Having to decide, therefore, the correct order of the cuttings, or having to recognize and discard material that has been seen previously, requires a lot of experience. Fortunately, the experienced site geologist is more likely to place all of these sometimes random cuttings into the stratigraphic column in the log properly. His third challenge is to be on the lookout for disintegration. Disintegration is caused when the drill bit grinds up the cuttings into such fine particles that these particles dissolve into the water of the drilling mud. They literally disappear and cause a blank space on the log. The geologist must, therefore, be on the alert for disintegration so that he can use other tests to identify the type of rock that is in the formation but may be missing on the log. In any event, using the correlated data coupled with interpretative experience, the geologist prepares the report of the stratigraphic descriptions of the borehole from top to bottom. With the compiled data on the mud log from the driller, the mud logger, and the geologist, the drilling department is able to determine the depth of the well, calculate the different drilling zones as measured by the rate per hour the drill bit passed through the various rock types, check for oil and gas shows in the mud, collect and analyze the cuttings for their characteristics and lithology, and place the cuttings at their appropriate placement as they might appear on the stratigraphic column. These formation evaluation techniques, however, give them only a partial interpretive view of what is there in the subsurface. For instance, when the driller notices a jump or break on the drilling log, he performs a bottoms-up circulation. This break in the mud log may be the first indication of reservoir rock with good porosity. This preliminary data from the mud log can only suggest the potential of a reservoir. Procedures and tests to collect actual samples and test for formation characteristics and fluid pressures and volumes will have to be conducted. Remember, conducting the following series of procedures is so important, in fact, that the Society of Petroleum Engineers requires that when a company claims it has found a new oil or gas reserve, actual production and formation tests under SPE best practices must be conducted. Please refer to Chapter